Example 3. In the diagram, the particle is in equilibrium and we need to find the values of f and alpha. This example might look similar to the last two we've tried, but it is different in one key aspect, and that is that we don't know the magnitude of force F, and we also don't know the direction that it's acting in. So for a single force, we don't know the magnitude and direction, and that means we need a slightly different approach to what we've seen previously. We'll start by resolving vertically. The component of F in the vertical direction is F sine alpha. We also have the 9 Newton force acting downwards, so that's -9, and we can ignore the 8 because that is acting across. It's in equilibrium, so the right hand side is 0. I'm just going to rearrange this to give us F sine alpha equals 9. We can't do much more with this yet because we've got two unknowns. What I am going to do though is label this equation 1 so I can refer back to it later. Next, I'm going to resolve horizontally. I'll take right to be the positive direction. This time we're crossing the angle, so we have F cos alpha. We've got an 8 Newton force in the other direction, so -8, and that equals 0. We can also rearrange this to give F cos alpha equals 8. And we'll label that equation 2. Now there's more than one way to solve this pair of simultaneous equations, but I'm going to use the fact that this equation contains sine alpha and this equation contains cos alpha. We have an identity involving sine alpha and cos alpha, and that identity states that sine alpha over cos alpha is tan alpha. Using this identity, we can divide equation 1 by equation 2. On the left hand side, that gives us F sine alpha divided by F cos alpha. On the right hand side, we get 9 over 8. F divided by F is 1, so they cancel. Sine alpha over cos alpha gives me tan alpha. And then if we do inverse tan, we get alpha equals 48.4 degrees to 3 significant figures. Now that we know the value of alpha, we can sub back into either of these equations to find the value of f. So using equation 1, we get f equals 9 divided by sine alpha. Don't forget to use the exact value, which gives us 12.0 to 3 significant figures. Okay, here's one for you to try then. Pause the video, have a go, and then come back and check your solution with mine. Welcome back, here's my solution to this problem then. This time, we've got two unknowns, t and y. We'll start by resolving vertically. I'll take downwards to be the positive direction. To resolve t in the downwards direction, we're not crossing the angle, so that will be t sine y. In the opposite direction, we've got a 14 Newton force, and it's in equilibrium, so that equals 0. Rearranging, we get t sine y equals 14. We'll call that equation 1. Next, we'll resolve to the right. This time, we are crossing the angle, so we'll get t cos y. We've got an 8 Newton force to the right, so that's plus 8. And a 26 Newton force to the left, so minus 26. And that equals 0. Rearranging, we get t cos y on the left hand side, and 26 minus 8 is 18. We'll call that equation 2. Dividing 1 by 2, on the left hand side, t sine y over t cos y will simply cancel to tan y. And on the right hand side we have 14 divided by 18, which cancels down to 7/9. And if you pop that into your calculator, you'll get y equals 37.9 degrees to 3 significant figures. Substituting back into equation 1, we get t equals 14 over sine 37.9. Which gives us 22.8 newtons to 3 significant figures.